Alright, this is the Pre-AP Algebra 2 Inverse Functions Test Review. Number 1 says, if f of x is a 1-to-1 function and f of 4 equals -2, f of 12 equals 5, and f of -3 equals 3, then create a table of values for the f inverse of x. So, as a reminder, this number that I'm plugging in, this number that I'm plugging in, this is the x. That's what I plug in. This right here is the y. That's what I'm getting out. So I know that I have a point at 4, -2. There's also a point at 12, 5, and -3, 3. So to write a table of the inverse function, all I have to do is switch my x and my y. So I'll have a -2, 4, 5, 12, and 3, -3. Number 2, find the inverse of the 1-to-1 function. Okay, step number 1, swap the x and the y. So x equals 2, y plus 1 cubed minus 5. And now we need to isolate our y. First thing I'm going to do is add 5 to both sides. So x plus 5 equals 2, y plus 1 cubed. I need to divide both sides by 2. So x plus 5 over 2 equals y plus 1 cubed. Now to get rid of that cube, I'm going to take the cubed root of both sides. So what I've got now is the cubed root of x plus 5 over 2 equals y plus 1. The last thing I got to do is subtract 1 from both sides. So my final answer that I'll go ahead and write in function notation, the f inverse of x equals the cubed root of x plus 5 over 2, and then on the outside of that, minus 1. Alright, number 3, find the inverse of the 1-to-1 function. Same process. Let's swap the x and the y. X equals the square root of 3y plus 1. To try and get y by itself, the first thing I want to do is square both sides. That way I can cancel out that square root symbol. X squared equals 3y plus 1. I'm going to subtract 1 on both sides. So x squared minus 1 equals 3y. Divide everything by 3. So I end up with the inverse. Well, I'll go ahead and write that. Divide by 3, divide by 3. The f inverse of x is equal to x squared minus 1 over 3. Next one, true or false? For a function to have an inverse that is also a function, it must be 1-to-1. That is true. If it is not 1-to-1, it will have an inverse, but that inverse will not be a function. It needs to be 1-to-1. Oh, I'm stuck. Okay, moving down. Hello. There we go. Number 5, if f of x and g of x are inverses, then f of g of x equals x, and g of f of x equals x. Not negative x, not 2x, not x squared. It has to be just x. Number 6, find the inverse of the 1-to-1 function. Alright, we got another one. Let's swap the x and the y. X equals the cubed root of y over 3 plus 1. First thing I've got to do is get rid of that cubed root. I'm going to do that by cubing both sides. So x cubed equals y over 3 plus 1. Subtract 1 on both sides. So x cubed minus 1 equals y over 3. And finally, I'm going to multiply both sides by 3. I'm going to multiply this whole thing by 3. So y equals 3x cubed minus 3. And I'll put that in function notation because that is a function. The f inverse of x equals 3x cubed minus 3. Number 7, calculate the inverse. Is the inverse a function? Let's find out. X equals 3, y minus 4 squared plus 9. Let's get y by itself. I'm going to subtract 9 on both sides. So x minus 9 equals 3, y minus 4 squared. Next thing I'm going to do is divide both sides by 3 to cancel that 3 out. So x minus 9 over 3 equals y minus 4 squared. Now I got to take the square root of both sides. That way I can cancel out that squared. So the square root of x minus 9 over 3 is equal to y minus 4 because I took the square root of both sides. But because I took the square root of that left side, I also have to remember that I've got to put that plus minus symbol because I have a positive answer and a negative answer anytime I take a square root or any even root. So to continue isolating y, I need to add 4 to both sides. So I end up with y equals 4 plus or minus the square root of x minus 9 over 3. That is the inverse of x, but because it has that plus minus, this is not a function. The plus minus means it is not a function. Okay, number 8. If the two graphs shown are inverses of each other, what is the x-coordinate of E? What is the y-coordinate of point A? Okay, well, if these are inverses, that means that this is just this one swapped. So I'm swapping the x and the y. So the ordered pair here, instead of being -5, -2, would be -2, -5, meaning the x-coordinate of E would be -2, because that's my x-coordinate. I'll write it right here. X-coordinate of E is -2. The other question, what is the y-coordinate of point A? Well, A corresponds with this point right here, so since this one is 1, 0, this one is going to be 0, 1. So the y-coordinate of A would be 1. Next page. Board is going slow. There we go. All right, number 9. The graph of h of x is given to the left. What is one possible value for f inverse of 1? Since I am looking for the inverse of 1, I am plugging 1 in instead of y. So I'm going to go to where y is 1 and follow along, and I see two possible options. It could be this point right here. It could be this point right here. So it could be 2 or 4. It only asks for 1, but those are your two possible answers. Number 10, what does it mean for a function to be 1 to 1? If it is 1 to 1, it passes the horizontal and the vertical line test. It also means the inverse is a function. If it's not 1 to 1, the inverse is not a function. Number 11, when given two functions, describe two ways to algebraically determine whether they are inverses of each other. So one way is to take the inverse of an equation. Oops. Take the inverse of one of your functions, and compare it to the other. If they match, it is an inverse. The other way that we can determine is by doing composition. We can compose f and g, or whatever the function titles might be. And if we end up with just an x, then it is an inverse. If we end up with anything else, it is not an inverse. All right, moving on. Stop. Okay. If f of x equals 2x minus 6, which graph on the left is the graph of the f inverse of x? Now there's a couple ways to do this. I'm going to do this first by hand because I could have put this in the calculator, but let's say, for example, that maybe this question is not on a calculator section. So let's start by taking this equation and let's find the inverse. X equals 2y minus 6. Let's isolate y, so I'm going to add 6. X plus 6 equals 2y. Divide everything by 2. So that's the same thing as the f inverse of x equals 1/2 x plus 3. Because as a reminder, if I have two different things in that fraction dividing, I've got to be sure that that 2 goes with each of those terms, not just one. So when I simplify each one, that's what I end up with, 1/2 x plus 3. So I definitely recognize this format. That's just a linear function, right? That's my y equals mx plus b. And if we remember this from Algebra 1, I know this 3 is my y-intercept, so 1, 2, 3. And the 1/2 is my slope. That's my rise over run. So from here, I should be going up 1 over 2. This is my answer. This line would be the inverse of f of x equals 2x minus 6, which should be line 2. Now, if you did have your calculator, you could graph this. You could graph your original function, and you could see which one of these is reflected over the line y equals x. Because, as I see here in this next question, it says the graphs of functions and their inverses reflect across the line y equals x. Remember, that's that parent linear function that just goes through the origin, has a slope of 1, so it's up 1 over 1. So it would be reflected across that line. Number 14, if 100 is in the range of f of x, what conclusion can be made about the f inverse of x? Well, because I know that range is referring to the y values, and I know that an inverse just swaps the x and the y, if 100 is a y value of f of x, 100 is also going to be an x value of the inverse, or 100 is in the domain of f inverse of x. Number 15, find the inverse of f of x equals 15 over x minus 5. Let's swap the x and the y. X equals 15 over y minus 5. I'm going to slide this a little bit. Come on. Come on. Come on. Okay, there we go. Of y minus 5. Anytime I have a y stuck in the denominator, my first step is to get it out of the denominator by multiplying both sides by the entire denominator. Because those cancel out on the right side, and what I end up with is y minus 5 times x equals 15. Sorry, my board is running so much today. That says y minus 5 times x equals 15. Now there's a couple things you can do from here. You can distribute or you can divide by the x. I'm going to distribute to get xy minus 5x equals 18. Next step to get y by itself is to add 5x to both sides. So xy equals 18 plus